Okay, first of all, we will discuss .1x. In shortcut, we call them .1x. By the way, it is IEEE 802 .1x. And shortcut, we call them .1x. Okay, IEEE we already know is an organization, and 802 is February 1980. They introduced this type of protocol. So that's why they call them, there is a full family of this protocol, but the one which we are interested is IEEE 802.1x. okay, with X there is A, B, C and so many other. There is a full family. Okay, so IEEE introduced 802.1x, and shortcut we call them .1x. Okay, so it's a port-based authentication, a secure way to authenticate user or machine, okay, into your network. So it is a port-based authentication method, and this authentication method work on OSI model layer 2. Definitely when a user try to connect, so the user is either the machine is connected to your access layer switch. So it provide port based network access control using authentication method, and this method service is called port level authentication. Now the protocol which is used in IEEE.1x is called EAP. EAP means encapsulation over LAN. EAPOL. In short, we say like this: encapsulation over LAN. So it means 802.1x use extensible authentication protocol to exchange the messages. EAP, we call them EAP, either E. So we use .1x to prevent unauthorized device to gain access to your network until and unless the device is not authenticate, not authorized, so their device or user will not access your network resources. So in short, we can say that .1x is a standard which provide authentication and authorization services at a network port level. So it means when a user try to connect to your network, first they need to authenticate, and then based on authentication, Cisco ISE will provide them authorization, which resources and services they can access. Keep in mind we use 802.1x for both wire and wireless. So you can use this technology, this security mechanism for both wire and wireless network at layer 2. So if I say that .1x authentication is a client server based authentication, so it will not be wrong. I will show you a bit later. So when a user try to connect, by default endpoint is unknown and all traffic is blocked except EAPOL, and I told you this the protocol which has to carry your authentication encapsulation over LAN. So let me show you. So suppose this is our switch port and here is a user. When he try to connect a cable here, so all the traffic is blocked like a DHCP, TFTP KBROS, HTTP, HTTPS, every sort of traffic is blocked by default. When you configure .1x on this port of Cisco switch port, beside only EAPOL, encapsulation over LAN protocol, and when the user is authenticate and everything is okay, then the rest of the traffic will be allowed, like a DHCP, TFTP, HTTP, whatever you want to access, it will be allowed as per authorization policy. So it means is a high secure mechanism. No user, no machine is allowed to access anything until and unless it has been authorized, authenticate and authorized. Only this protocol will work. I will show you in the lab. I will capture the packet. I believe I already captured the packet as well from my lab. This the EAPU, okay? And then the other side, that will be a radius. So that's the way how .1x work. So this is before and this is after authentication. So before authentication, nothing is working beside EAPOL protocol. Now before going in deep, you need to know that we will discuss supplicant, authenticator and authentication server in next slide. But right now you need to know that between client and switch, this connectivity is point to point, layer 2 connectivity, I would say. And between switch to Cisco ISE is layer 3 connectivity. Second thing, you need to know that from your client, which we call them supplicant, endpoint and device, a protocol which is running as EAPOL, which I told you, encapsulation over LAN. So this protocol is working between your client and switch. Switch convert these to radius. From switch to Cisco ISE, it will be a radius protocol. So it means two type of protocol is running. Also two type of connectivity is there. And whole picture, we have three type of things: supplicant, authenticator and authentication server. Forget about these three terminology, we will discuss a bit later. But right now you need to know that a client is normally connected through layer 2 to your access layer switch. From access layer switch to Cisco ISE, we are connected through layer 3. Then a protocol which is running between your client and switch is EAPOL. And a protocol which is running between your access layer switch to ISE is radius. Okay. So what happened when a user try to connect endpoint and device, supplicant? So they are using EAP protocol, which we discussed above, extensible authentication protocol. They need to put certificate because it's through, we will see in the lab, through certificate we can also authenticate. It should be a password, it can be a token, and it can be a username and password. They will put the credential as a .1x, this supplicant endpoint, and they will send them to network device, means authenticator, means access layer switch. What switch will do? They will make the radius. They will not send this one. They will send as a radius packet to Cisco ISE, which we call them authentication server. And if we are using identity store, external identity store, when this user try to log in from laptop, desktop or whatever through Wi-Fi or whatever, if we are using external identity store, then Cisco ISE will check with Active Directory username and password. And what will happen? They will say it's okay. Active Directory say that yes, username and password is yes available with us. Cisco ISE will send the request to network device that authenticate and authorize this port, and this way this user will be authorized to connect to the network. If authentication is failed, then the port will be unauthorized. Again, we will discuss a bit later in .1x what is port authorized, port unauthorized, and auto. But anyway, if authentication fail, this device will not access any resources. Even they will not get an IP address. It depends on your configuration, but normally. So this how this thing are working. EAP means extensible authentication protocol. So between endpoint and device supplicant to Cisco switch, we are using EAP. From Cisco switch to Cisco ISE, we are using RDS, which I told you above. ISE will check the username and password from their store. It can be internal store and it can be external identity store. It can be some other thing as well. And this how the end device will connect using .1x. They send everything through EAP. Cisco switch sent through RDS. Cisco ISE authorize and authenticate the device and it will connect. Now this is the whole process. When a client try to connect through .1x, so they will send EAPOL start message. Then it will be EAP request identity message. Switch will port is unauthorized. Keep in mind, when a system try to connect to Cisco switch port, so port is unauthorized by default. Nobody is allowed beside this protocol, which I told you above here. Nothing is allowed. Only this protocol is allowed. Because why this protocol is allowed? So carry your data, your authentication mechanism, which I show you here, to take your credential, your certificate, your password, your username and password, your token, to present to switch that yes, I have authority to access the network. Switch will say, okay, just wait a minute, let me check with ISE. ISE will say, okay, just a minute, let me check with Active Directory that this username, this password, this username is there. Either this certificate is from certificate authority or not. And then this user will grant access. But how all these things are working is like this. So client will first send port is unauthorized. He cannot access anything beside this protocol is work. Will send this start. Then Cisco switch will send RDS access request to Cisco ISE. Then there will be EAP request identity, EAP response identity, EAP request OTP, and EAP response OTP, and EAP successful or may be rejected. But from switch to ISE, they will use RDS protocol to communicate. I told you. So it means two type of protocol will run in .1 in the case of .1x. So there will be RDS access request, RDS access challenge, RDS access request, RDS access accept, and RDS accounting start. Because whatever this system is doing, so accounting will start and they will capture all the detail. And port is authorized now. And when the system is log off, so the port will be unauthorized again, and RDS account will stop that yes, this user log off from here and he left the office. Now these are the history, what he done when he came in the morning 8 a.m. and left 5 p.m. So all the detail is the job of accounting. And these are the capture which I take. From client to Cisco switch, they were running EAP protocol. And these are the request identity and request, and first time has failed. So that's why it's failed there as well. But just to show you, and I capture only EAPOL, encapsulation over LAN protocol. And when I capture from switch to Cisco ISE, so there were RDS running. Access request, access challenge, access request, access challenge, request accept, accounting and accounting start, whatever I mentioned here. So this how's .1x working, keep in mind. It's the full process how .1x working. So it's a secure mechanism to prevent unauthorized device and user to access your network. So when somebody tries, suppose this is my topology and this is my PC. So when I connect to access layer switch will say, okay, wait a minute, let me check with ISE. So they will check the detail with ISE. ISE will say, okay, you are using E1. E1 is our user and password is abc@123. Let me check with Active Directory that this user is there or not. Active Directory will respond them that yes, E1 and password ABC is there. ISE will send radius to this switch. Now between this PC and this one, there is EAPOL protocol running, and from switch to ISE there is radius running, and under this port we configure .1x so that nobody can join without authentication. This how it is work. Okay, let me show you. We will do lab later on. Forget about, let me show you how it is work. So let me on this PC1. Okay, this PC1 already joined this Active Directory. We know this one. Okay, so let me log in. Okay, yeah, before login, what I will do, let me capture this port 0/1 where PC1 is connected. So right click on my PC, capture and 0/1. Let me capture this port. Okay, and just wait a minute. Okay, let me on this one. Yeah, okay, this one is done. Okay, second thing, I need to capture this port where is going to ISE. Either I can capture from here, this 0/1. So when they are receiving, either I need to capture here, it's up to you, anything will work. So let me capture 0/0 interface. So from 0 to this one it will be radius, and from here to here it will be EAPOL protocol. Okay, so I start to capture, and now let me log into PC and see if .1x is running. So abc@12345. Suppose this user try to log in, and let me stop this one, and let's go to 0/1. This is 0/0. I need to go to 0/1. Here you will see EAPOL. You see, this is the detail. Request is the start, and you can capture in .1x. You know this, they are using .1x authentication mechanism, and we are using layer 2. It's a layer 2 technology. I told you source and destination port and everything is there. Type a start, then request. This the thing which I mentioned, EAPOL start, then EAP request. So there will be request, then that's the request. If I click this, the request detail, extensible authentication protocol, and code is request. So we say this one, this the client will send a request, then EAP response identity. So there will be response. Yeah, that's the third packet, and it's a response, code is response. And again we are using extensible authentication protocol, which we discuss. And they mentioned that I am a C1. C1 is our user which try to log in from here. That's what we are talking about, and that's what we say here, that this protocol will carry on certificate, password and token. It can be anything. We can do certificate based authentication, username and password, machine authentication, token, and so many other things. But anyway, let me come here. So that's the response identity. Then there will be EAP request OTP. So there will be request OTP. I did need to check because they're using certificate. So I need to, okay, there's certificate detail, client hello and everything. So I need to check. This is also response, and this is also a response, and then it's successful. So it means they are using different method, but anyway, that's the way, because the last one is EAP successful. So it's successful. This is the last packet. Extensible authentication protocol success, and then accounting will start, which we say here, but that will be on the other side. Forget about. So these are the packet which I show you from my client, and my client is PC1, and I capture 0/1 interface. You can see it's a 0/1 interface of the switch, and we see that this protocol is running because .1x is already enabled. Forget about, we will do a lab from scratch in next video. This is just to show you how it is work. Now coming to what happened when the switch receive these detail. So they will send, because 0/0 interface is connected to ISE, and I capture 0/0 interface as well. Here there will be radius protocol running, so I need to capture radius, and these are the radius detail, because I told you from client to switch it will be EAP. Well, from switch to ISE it will be radius packet. They will convert them in a radius, and here it's a access request, access challenge, access request, and radius is running. These are the code. Access request, this what I say, yeah, access request, access challenge, access request again, and radius access accept, and radius account start, and these are the packet which we can see from here. Access request, access challenge, access request challenge, and later on there will be access challenge accept. Here is, and now at the end account will start. Here is accountant request, and then accounting response request, and everything. And these are the packet detail. We will do later in the lab. I don't want to make you confused, but this how .1x work. And I capture these packet for you as well, and I put them here. This how the whole process work of .1x. So I hope so you get the idea what is .1x. Okay, it requires supplicant to be installed. That is a separate thing we will discuss, and there should be configuration on switch side, then .1x will work. Again we will discuss, and the device has to be registered on Cisco ISE. Again we will discuss, but right now at least you get idea what is 802.1x.